what is this weird thing we built? Well, I was browsing the internet a couple days ago, and I found this weird video by Found and Explained that you should definitely check out. It is the Martin 262 Convoy fighter. It's got a weird propeller in the middle. I've never seen a model of it built, and I don't know if this thing will actually fly, but we should definitely build it because no one's made a model of this thing, and this thing never got built in real life. So where do we start? First, we do a lot of drugs because I'm pretty sure the people who designed this plane did a lot of drugs. I'm just kidding. We're going to jump into CAD, and then we're going to make the complicated spinning propeller gearbox doohickey because that is interesting to me, and I'm going to show you what we're going to do. The most complicated part of this aircraft, this central rotating mechanism that's going to hold the propellers and the gearbox and everything else, and all the wires are going to run through it. We need to make it kind of big because I have to build a fuselage around it and make it a pretty decent size so we can make it easy to fly. So 140 millimeters is about the size from here to there. It's also going to have 3 propeller blades because the real one has 3 propeller blades. We're going to lighten up some of the insides because less plastic is mo better for airplanes because weight is bad. For this part, we do need a way to transfer torque to the rotor from the motor, so we're going to print gears. Fortunately, the Bamboo Lab printer that I'm using for this thing is literally amazing at making gears and everything else. This gear, I'm pretty sure will be just fine printing it out. We're going with a 2-to-1 reduction, so I have a 50-tooth main gear and a 25-tooth spur gear, so basically it's going to be like a 2-1 ratio, because I need to make sure the clearances fit, because this motor has to go inside this gear race on the inside, and the propeller is going to be on the outside. I'll explain the propeller calculations a little bit later, but it'll make sense why I think this will work and load the motor correctly. Okay, now we're going to make this clamp for the motor to the shaft. I think we're literally just going to make this piece of plastic and put some holes in it, and then we can just clamp it to the carbon fiber tube, and the motor mounts to this. I mean, time will tell if this will be strong enough because when this thing spins, this motor is going to try to unseat itself from this gear, but if it explodes, and I need to redesign it. For now, I'm going to go with this dinky plastic thing to see if this thing will actually hold up or not. So we have a completed motor rotor assembly. There's also another extra set of blades now because it produces a lot of torque, so to reduce the amount of torque, I made an opposite rotating one because the Martin 262 that we'll be building will have this feature. Yeah, about 60.6 ounces of thrust. Is that a lot? Specs for this motor that we are using in the doohickey with this propeller on a 3-cell battery, which is what we're running. 26 amps. We're pulling a little bit more than 26 amps. I'm going to ignore this feature and hopefully the motor doesn't explode. But it produces 12,050 grams of thrust, 44 ounces. So we are losing a lot of efficiency with this setup I have. We're drawing a lot more amps because of this weird gearbox configuration. The aero resistance of the spinny doohickey is also eating into the power that could be going to the propeller. That thing is really inefficient. Pretty sure a lot of this efficiency loss has to do with this rotor itself, these vanes running through the air, the mass of this, some of the drags, and also these ends eating into my possible thrust. So it's not the greatest thing in the world. Let's take a step back and look at the flow chart of frustration because that is where this project is going to go because it's a very complex, weird thing that I have to figure out. We're doing the CAD, and next up is the electronics because we have to devise a weird control mixer doohickey for this. I'm looking at this thing. I've decided this thing to have a X tail, so it's a little different from the original, which has a Y tail with 3 surfaces, but I'm going for 4, because we're going to make all 4 control surfaces control pitch, roll, yaw, well, yes, that. But I'm trying to figure out how exactly I want to do that, and I've decided to do something a little different than I normally do. This looks correct. We're going to upload it to an Adreno, and I'm going to use an Adreno for the mixing. So the RC transmitter only has to do its standard protocol of outputting a PWM signal to control pitch, roll, and yaw. There were some little fun bits. AI is pretty cool, but it's also kind of dumb sometimes because it didn't really quite understand my question. My initial question was if it could create this mixer doing this. I actually kind of reflected and thought about what it fed me the first time and actually gave me something a little more useful, which is this. So we're gonna try this. But let's see if it blows up when I plug it in. It should work. That looks normal. That did a thing. Currently nothing. I have to do more troubleshooting. Yeah, I really screwed up here. ChatGPT or the Adreno, for whatever reason, does not work, and I'm not smart enough to figure out why it doesn't work. It looks right to me, but I am not an expert. I can download code, I can upload code, and that's all I can do. It turns out I'm really stupid, so the only solution here, download NAVY VTOL. This uses the TNC microcontroller and some gyros and stuff. And Nicholas Rehm, he's got a cool YouTube channel you should definitely check out. It's got these crazy VTOLs. I met him at Flight Fest last year. Super awesome. If you want to build anything wild, this is the code to do it with. But I'm still an idiot, so I built this. This is a test platform. It basically mimics the functions of the big one that we're building, but in a smaller, more durable package that I don't really care about if I crash because I don't understand what I'm doing and I'm going to make a mistake. Look at me, I can do code. I spent about probably an hour doing this little segment here. When you use the Adreno, you can comment things out and turn lines off. I don't know why I'm talking about this because probably none of you are going to build this weird complex thing, but I'm going to turn it on. Let's try to fly it. All right, let's plug this doodad in. Let's see what happens. And you can see when you move it like this, the fins move. Like rolls it. This is yaw. I'm counting it as yaw, but it looks kind of like roll, I guess, depending on what you think about this. This is how pitch works. It's like an X configuration. So it has to vector multiple thrusts along multiple axes to stabilize. These vanes are basically fighting whatever reaction happens to the aircraft. So now we just take off. Okay, maybe it needs some adjustment. Hey, it was kind of working. Yay, and I landed it. Okay, well, we got this flight controller thing figured out. It's time to stick it in something. I'm not going to stick it in the thing right away, even though we're building that. So we're going to make a test airframe, because that is the logical thing to do if you don't like wasting a bunch of time destroying a bigger version of the small project you're working on. Basically be this thing here. Go like that. It's going to have its little wings here, and it's going to have its little control surfaces here. So the propeller is in here, and then it's going to have a little smiley face. Once the test frame's done, hover flight. Behold, the thing I drew. It's having a seizure. I should fly it. Wow, it works great after a couple of screw around sessions. And look at it, it's amazing. After the hover flight, we now go towards the field for a forward flight session where we take this crappy little airplane and try to fly it like we would the real one, because it's a lot cheaper to crash a small one, and I won't really care as much. Okay, gyros seem to be working appropriately. All we gotta do is just take off. Okay, stop having a seizure. I know you're cold. That hover is great. All right, forward flight mode. That checks out. It's like a weird-looking missile. Man, it flies really good. All right, I'm gonna pop it back into hover. Just like that, it goes right into hover. That's awesome. Okay, that was awesome. It flies great. I have very high hopes for this. Let's stick all these guts in the semi-scale airframe. It's only kind of a partial representation of where we're actually going. It's going to have like a full 3D printed fuselage and look super cool. But right now, it's just this piece of foam, because if it crashes, I won't be as mad. Look at it, it works. That's amazing. This is also the first time I've done any sort of aircraft that has this X-tail mixing, which is very non-traditional for most RC airplanes, because they have a tail, which consists of an elevator and a rudder. Very easy to look at. You understand that from code. This is a nightmare. It looks ridiculous, because you have positives and negatives that all have to combine and mix to make this thing function the way it's supposed to. I just kind of figured out how to do it by staring at it until I got an aneurysm. Anyways, it's time for that aneurysm to take flight. This is the center of gravity, which is important for forward flight, and it about checks out. Maybe needs a little more nose weight to balance correctly, but I'm sure this is going to be an excellent airplane. When I say excellent, I mean kind of crappy because it can't land because it doesn't have wheels. But there's only one way to check it out. Let's put it on my new tether system. I think it's more than 60 ounces. Like, it's heavy. Gyros is right. You know, this is roll. This is yaw. And it behaves as expected. Engaging motors. You ready? Oh, let's go. crap, that is impressive, and I really don't know how much 60 ounces weighs. That is freaking awesome. It is very controllable. I was not expecting that. I was expecting this to be a lot more aggro and worse and behaving like a drunken child. If you give children alcohol, I don't think you're supposed to. Dave, you said something interesting. What if we moved the CG down here and would it be more stable? Because it's like a pendulum, right? But that's the fallacy, the pendulum fallacy with these airplanes. Now, if you think about the way this thing is controlled, it's manipulated by these vanes here, the control surfaces, if you will, and that controls our pitch, roll, and the yaw. And you can think of the airplane like this. I have a harder time keeping it under control if we just move all of that, because now I'm fighting a lot more to kind of keep it steady. Now we flip it like this. Notice how easy it is to keep it steady? All that mass is up there. So there you go, a little bit of science education lesson with the pendulum fallacy and stability of aerial vehicles. And then we test flight. We're ready to test fly this. It seems fine, but every now and then I move the controls and I get this weird little error right there. That's like a weird micro jitter where the control surface all seize up and stop working, which isn't great for a VTOL because you need your control surface to work. I don't really know how to diagnose it, so I'm just gonna fly it. Ready? I'm gonna go up pretty quickly. All right, here's the maiden flight. Hopefully it works. Oh no! I gotta rebuild it. I just stopped, like the controls went completely dead. I had throttle response because I have a pass-through, but the flight controller just like turned off. Well, that sucked. That didn't work at all. It could have gone better. I think maybe the positive or negative wire that controls the servos was the thing that came undone. I just didn't really diagnose it correctly at the field. Because, yeah, maybe it just took off and it came unplugged. Because that's what it looked like. Because I had throttle control and everything, but no tail control surfaces were moving. They were not responding to the flight controller. They just went dead. But I don't know if the flight controller turned off and decided not to do anything. But, you know, maybe it was too cold. So we still have some problems we need to figure out. So rather than going to the 3D printed final frame, we're going to do this back from this flow chart up to here into the semi-scale frame, and we're gonna fly it again. Okay, it's back together. We made a quick few changes. I isolated the motor controls from the flight controls, and we used heavier gauge wire and everything soldered. What do you think? Is it gonna make a smoking hole in the ground? You weren't here for the last crash, but
I got my hopes up.
all right, ready? Here we go.
Yeah.
Stop working into the same thing! Wow, would you look at that? It didn't work either. It crashed again. I've hit our smoking hole in the ground. I'm getting really frustrated here. We need to do this one more time. So we'll go back up here, and I'm going to tweak a few more things. I put this back together, and I'm trying to diagnose this and do my little NTSB report. And oddly enough, all 4 servos that control this plane are dead. The last crash killed 2 of these servos. I don't know what's going on here, but all 4 of them are dead. I've diagnosed them. They look totally fine, but for some reason, they just don't work. Which leads me to a number of problems, because basically what this plane does is it takes off, I transition to forward flight, and not a second later, all the controls go dead. It did the exact same thing it did yesterday and just crashed into the ground. Which leads me to believe there's either a power supply issue to the servos, which I've verified is not. It's a receiver issue, which it is not, because I've taken this outside and tested it on the ground walking far away, and they all seem to respond fine. Or 3, there's an issue with the flight controller turning on and off. I don't really quite know if it's that, but I have my reservations and thoughts thinking it's not really that rebooting or doing anything, because all 4 servos are actually just now dead. Which leads me to think it's because of the routing inside this airplane. Like if you see over here, this carbon rod is holding all of our electronics. Like all 4 servo will go through this carbon rod, through this combined cable here, and a supply cable, which I've yanked out in frustration. But here's the fun part. The motor phase wires for the rear motor are going through the same wiring loop, like over here. the rear motor has to be fed from somewhere, and the battery is in the front of the airplane, which feeds these two speed controllers, which feeds the motor. But this motor wire needs to get power from somewhere, so I put it right through the rod just to make sure we can get the plane to balance, so I put the battery right up in the nose. Well, this is the problem, because all these wires go through a rod that's like maybe 10 millimeters in diameter on the inside, which puts the signal wires in really, really close proximity to the pulsing electrical wires for the brushless motor. I'm not an electronics engineer by any means, but I think there's something going on here. So this is what I'm going to do. Removed the gyro from up here, place it down here next to the servos, so the servos no longer have to talk through this tiny little carbon rod next to these really, really noisy electrical interference from these motors, because there's probably all sorts of like EMF issues or other electronical nonsense. I sound really smart. I'm really not that smart, but I'm pretty sure that's what's causing these problems. Shut up, Steven. So now it has its own receiver. We also did test this today by putting 2 receivers in the airplane because I noticed we were able to recreate that weird jitter we had earlier, and isolate it by putting a receiver for the zone speed controllers and motors, so that is isolated. But now it's completely fully isolated, got its own receiver, got its own battery, and all it has to do is talk to the servos and not crap anything else up. The other receiver is just running the speed controllers and this doohickey and the motors, so full isolation. Let's go crash this setup now. It's rebuilt. It looks like complete crap. I don't care anymore because right now it keeps smashing my hopes and dreams into the ground. I'm gonna have Sam do some quick ground run-ups. I'm gonna start the throttle, hit the transition switch, and have him tilt it, and we'll see if anything happens. As long as I maintain control of the servos, then we'll throw it in the air, and hopefully I don't get round 3 of the same problem. Start a little bit.
One.
Still work. Yeah, it looks fine, okay. So I definitely adjust the gains a little bit, but it is definitely flying. We finally got it to transition and fly like an airplane. I don't know if that's actually gains or if that's the, oh, I know what it is. It's the crappy construction. So you're seeing the tail all floopy flops around. It's like a feedback loop because the gyros are attached to the tail and the tail itself is flimsy. So it causes all these weird oscillations. Let's put it back into hover. We're gonna run into problems here. I don't think I can transition back into hover. Alright, we're gonna land it. Something happened, it made a weird sound. One of the rust bearings is sliding out of my assembly, so I think it just skipped some teeth there. This looks great. I'm gonna rebuild it again. We're gonna make this a little bit nicer, and I'm gonna do some more gyroscope vibration isolation to hopefully remedy some of this switching problem. But hey, it works! So now that it flies good with this ugly, non-cool looking frame, we can move on to the 3D printed final frame. Never seen this on the channel before. This is PLA. It's like paper, except it's plastic. A cool tip if you're working with this stuff. I tried cutting it, and because it's 3D printed, the layers just separate immediately and it breaks and it really sucks to work with. But if you heat up a knife, it just cuts through like butter and you don't get these little micro fractures in the corners which cause the parts to break up and delaminate. All right, it looks pretty crashable. All right, only one way to find out if this works or not. All right, here we go. All right, Sam, I'm gonna head towards your direction. Airplane mode. Oh yeah, here we go, we're flying. It works. I gotta clean up that scraping noise. Look at it go, it looks awesome. It's like a missile with wings. It's a little tail heavy, but I mean, yeah, we gotta change that a little bit later. Okay, back to hover. Oh, come on. Oh no, this is bad. This is bad. Okay, well, we didn't quite hover it back down, but we got it back down without totally smashing into a million pieces. Oh good, I don't have to reprint that. We broke a prop, I heard a crunchy sound. I think it was just the propeller. And would you look at that? That flies actually great. Gosh, the NTSB has concluded. My motor design sucks. Someone commented on Instagram, if you follow me there, that the way this gearbox works, the gear is going to be pushing away from itself. And you are right. This is in conjunction with the overloaded motor, which is getting a little warm. It's actually still warm. It's been quite a few minutes since we've just finished flying. And the motor mount, since it's made out of PLA, warps with just a little bit of heat. And that's exactly what's happened, because this is now melted and it's now pushing away. And now the gearbox is colliding into this outer ring here. And obviously we're skipping teeth. You can see the teeth marks there. That's an easy fix. I just have to design this a little bit better. I'm going to make this stronger so we don't have to deal with that as much. I'm going to have to reduce the weight. So we may fly without the fairing on the backside and try to keep as much weight up this thing as possible. Because right now everything is just kind of at its absolute maximum for this ring propeller design that I've come up with. And now I can add a second step, paint. So we're gonna paint this, and then we're gonna go to the field, fly for real. Oh my god, my handwriting is awful. It's cool, but it's weird. It just doesn't make sense because you have this crazy spinning, rotating mechanism, which is designed to take engine horsepower. It uses a turbine engine that drives like a turbo shaft, that turns this crazy gearbox, it spins these propellers around. There wasn't much information I found whether or not that this would be cyclic like a helicopter, which changes blade pitches to make it go forward and backwards and all that. So I'm assuming they're using the thrust from this to hit the control surfaces down here, which are comedically oversized, to control pitch, roll, and I assume yaw. Actually, well, you could do yaw with the motors, but I'm assuming it's a gearbox that's coupled together. So we did pitch, roll, and yaw with just 4 servos down here. This thing is like a prop hanging RC airplane, which uses a lot of thrust to force itself vertical, blow air over the control surfaces to make it stand up on its tail for hovering, which this has to do. My gearbox isn't really great so far, but I don't really think these motors are capable of delivering any more than they can deliver because they're overloaded, as in the previous test flights, which is why we really have struggled to get it back into a hover, because you need a lot of thrust over these little dinky control surfaces that I have comedically oversized to get the airplane to do what you want. And that is for a vertical landing. Now the problem is, every time we've tried this, there has been wind. And wind is the worst thing for a tail-sitting RC airplane, or any plane for the matter, because you have these things called wings. And they grab air, and they're trying to push the airplane all over the place, which begs the question, how is this thing supposed to land? It's supposed to have like a hook on the front, and you're supposed to fly up to the carrier aircraft, which isn't really even an aircraft carrier, it just happens to be a boat rigged for this thing, and it hooks onto a flying wire, and then it's grabbed by the boat. If you had to get out of this canopy because the ejection system didn't work, you would get minced by these crazy propellers. So yeah, let's go to the field and fly this thing for final giggles and cool B-roll. Oh yeah, it looks so cool. It's nice and painted. Well, I don't know if we're gonna be able to really VTOL it, so I took the back cover off to reduce the weight as much as possible because the motors overheat, and it's just overall not a great deal. But it's an experiment, so let's perform the experiment. Alright, it looks good, it's not crashing, so just gonna fly around. Man, that looks cool.
Whoa, it looks really cool through here.
Sounds awesome. Alright, I'm gonna try bringing it for a hover. Alright, we're coming. Hover.
Whoa.
It's back into a hover, but it's too windy. Whoa! Alright, I'm gonna land it as an airplane.
Oh.
All right, that feels great. I got it back into a hover, but it's blowing like 5 to 10 miles an hour, and this thing, you can't land it like that because it's moving like this, and if it hits the ground, it's just gonna bork over and just like break itself. I have to say that this, I would rank it as a partial success. If we were inside and I could fly this on a very, very closed loop environment with no outside forces, this thing would totally do it. It would hover and I could back it down and put it back on the ground. But unfortunately, we live in Ohio and it's very windy, which leads me to like the problem with this actual aircraft design is like, how the hell were they gonna land these on an aircraft carrier? The boat would be moving, it would be windy, and there's like no way you could get this thing to land on its little perch. It's a crazy concept for the Navy. This is a cool, real in-depth technology thing for me because I've tried so many new things. This is the first 3D printed airplane that I've like printed myself. It's also got crazy flight controllers in it that I've never really done before. So, I mean, it's a whole new experience. If you guys want to see any more weird VTOLs or crazy concepts, I look forward to exploring more of them because, yeah, this is exciting and fun. I learned a lot, and it was a pretty bad headache with a lot of things. That's it. Oh, oh, it broke not from the landing. It just flew over. All right, you ready?
Don't let it fall.